Hey everyone and welcome. Today we're going to pop the hood on self-driving cars and look at one of their biggest challenges, literally learning how to read the road. I mean, think about it. How do you teach a machine to understand all the different signs that guide us humans every single day?
Just picture a sign you see on your daily commute. Is it brand new and sparkling clean? Probably not. More likely, it's a little faded, maybe kind of dirty, or even partially hidden by a tree branch, right? Well, that's the real world that autonomous vehicles have to deal with. This isn't about recognizing a perfect picture from a book. It's about making sense of our messy, unpredictable reality.
Because really, that's exactly what traffic signs are, a visual language. And for any car to drive itself safely, it has to be fluent. This is a huge part of what the industry calls Advanced Driver Assistance Systems, or ADAS. And getting this part right is, well, it's absolutely fundamental to the whole idea of self-driving cars.
Okay, so let's get into the nitty-gritty. How do you actually teach a car to see? We're going to be looking at a fascinating study from researchers at Al Aliyah Amman University who took on this very problem, building and testing an AI model designed to master traffic signs. They did this using something called machine learning. Now, all that really means is that instead of trying to write a million lines of code for every single possible sign out there, you do something way smarter. You just show the AI thousands and thousands of examples, stop signs, yield signs, you name it, until it starts to recognize the patterns all by itself. So here's a look at how they actually did it. You can really break their process down into 4 main steps. First, they gathered a whole bunch of images. Then, their software got to work finding the key features, the patterns, in all those pictures. After that, they used all that data to train up a few different AI models. And finally, it was time to put them to the test. And, when I say a whole bunch of images, I'm not exaggerating. They used a public data set from Kaggle with over 2,300 different pictures of traffic signs. And these weren't all the same either. They covered 8 different categories, everything from stop signs to warnings about roundabouts.
And this is where it gets really fun. See, the researchers didn't just pick one AI and hope for the best. Nope. They set up a competition, an AI showdown between 4 different machine learning models to see which strategy would be the most accurate at reading the signs. All right, so let's meet our 4 contenders. First in the ring, you've got the decision tree, which kind of works like a simple flowchart. Then there's K-nearest neighbors, which decides what a sign is based on what it looks most similar to. Our third challenger is adaptive boosting, or ADA boost, which is super clever because it actually learns from its own mistakes. And last but not least, we have the random forest.
So to really get the difference between 2 of our main players here, think of it like this. A single decision tree is like asking one expert a bunch of simple questions to get an answer. But a random forest, that's like asking a whole crowd of 100 experts the same questions, and then you just go with whatever the majority decides. It's basically the wisdom of the crowd, but for AI.
Okay, so the training is over, the tests have all been run, and the results are finally in. So which one of our 4 AI models turned out to have the sharpest eye on the road? And this chart lays it all out pretty clearly. I mean, just look at these scores. The simple decision tree model, it did great, hitting almost 95% accuracy. K-nearest neighbors was even better at 98.3%. And ADA boost, the one that learns from its mistakes, got ridiculously close to perfect at 99.2%. All 3 are amazing scores, but somehow one of them still did even better.
And here it is, straight from the researchers themselves, the random forest model, the one that relies on that wisdom of the crowd idea we just talked about. It was the undisputed champion. It emerged as the best performer of the bunch.
Let that number sink in for a second. 99.8%. What that means is that during the test, the random forest model got the traffic sign right almost every single time. It's about as close to a perfect score as you can get.
And just to put that 99.8% in perspective, it's not just a good score, it's a new high score. This table shows how it actually beats the performance of other recent, very impressive studies. This is a legitimate step forward for the technology.
So, an impressive score in a lab is one thing, but what does this level of accuracy actually mean for all of us out there on the highway in the real world?
Well, it's pretty simple. The better a car can see and understand the world around it, the safer and more reliable it's going to be. That tiny sounding difference between 99.2% and 99.8% might not seem like much, but on the road, that could be the difference between correctly spotting a faded, worn-out stop sign at an intersection and missing it. Every single fraction of a percent matters, because it builds the trust we need to one day let the car take over.
So what are the big takeaways here? First, it's clear that AI can be trained to read our roads with truly amazing precision. Second, that wisdom of the crowd approach, the random forest, was the most effective. And that makes sense, right? One little part of the AI might get confused by a weird shadow, but the other 99 parts outvote the mistake. And that leads to the final point. This is a huge step toward building safer, smarter, and more trustworthy transportation for all of us. And that kind of leaves us with one last big question. As the technology itself gets this close to perfect, with accuracy hitting 99.8% and even higher, is the biggest challenge even about the code anymore? Or is the real hurdle now just us, our own human confidence to finally trust it and let go of the wheel? Thanks for tuning in.